So the question is a common question, integrate the following. So this question will be common, integrate the following. So we'll start with the first question. So the question is e power of tan inverse of x divided by 1 plus x square into dx. We need to evaluate this one. To evaluate this particular integral, you have to check which value has to be taken as t. So that is what we need to check. So to check that one, the question is which value has to be taken as t. Whether I have to take EA as t or whether I have to take tan inverse as t, whether I have to take 1 by 1 plus x square as t, which value has to be taken as t? That's the question we have. But if you try to differentiate one value, you should be able to get the other value. For example, if I take tan inverse as t, we know that the derivative of tan inverse will be what? Derivative of tan inverse of x will be 1 by 1 plus x square. That's the derivative you are having. So therefore, you can observe that this 1 by 1 plus x square is there over here. So therefore, you have to put the value of tan inverse of x to be equals to t. So put tan inverse of x to be equals to t. Therefore, if you try to differentiate this one, derivative of tan inverse will be 1 by 1 plus x square into dx is equals to, on the right hand side, you'll be getting dt. Now, if I try to plug in this value back over here in the given integral, I will be equals to this integral of e power of tan inverse of x is taken as t, and the remaining term 1 by 1 plus x square into dx is taken as dt. So now if you try to observe, this is nothing but the standard formula that we are having, e power of ax into dx is nothing but e power of ax divided by a, the coefficient of x, plus the constant of integration c. So here integration of e power of t will be e power of t itself divided by the coefficient of t is 1, so 1. Or you can just ignore that one value and just write it as e power of t itself. But t value, what you have taken? T value we have taken it as tan inverse of x plus the constant c. So that will be required solution. I is equals to e tan inverse of x plus c.